This is number 2 on the third part of the CP performance final review. I've got 2 dogs that are pulling a sled, and the mass of the sled is 300 kilograms. They pull it to the east across level ground. Fido pulls with a force of 10. Rover pulls with a force of 40, and there is also a force of friction of 20 newtons. Draw a free body diagram of just the horizontal forces acting on the sled. So you don't have to worry about doing the normal force for the weight. I'm just focusing on the forces that are either left or right, east or west in this case. All right, I've got Fido, and the 2 dogs are pulling to the east. Fido pulls with 10, and Rover pulls with 40. So I've got force from Fido is 10. I'd make sure I have an arrow, and it's pulling to the east. And then Rover has a force of 40 in the same direction. And then there's a force of friction of 20. And the force of friction is always going to oppose the motion. So the 20 is backwards like this. Force of friction. You have to label them. You have to have arrows. All right, what is the net force? So to find the net force, you just add up all the forces with appropriate positives or negatives depending on the direction. So net force, I'm going to have minus 20 because it's going backwards, plus 10 because it's going forwards, plus 40 because it's going forward. And I end up with 30 newtons to the east. Okay. That is the net force. Sorry, my computer was being crazy. What's the acceleration of the sled? So now I use the equation F net equals m times a, and I'm looking for the acceleration. F net from the part above is 30 equals mass, which was given in the problem as 300. That's a. Divide both sides by 300 to get the a by itself. The acceleration is 0.1 meters per second squared.